All right, so welcome. So this, so we have Philip Papadopoulos today. He's the director of Research Cyberinfrastructure Center. His team is providing scalable storage and computing infrastructure for faculty and research. Basically he's going to talk about storage.
Storage on this campus.
Yeah, so.
Yeah, storage on this campus. Look, I have about, I don't know, 20 or 25 slides, and it's much better if you have a burning question, just interrupt me. We're a small group, and even if we're a large group, I prefer talking to people, not talking at them. Of course, if you don't interrupt me, I'll just go. So what I want people to think about, because this has been, research data has been something, and where you store it for a research camp has been something that's been in my mind since about 2008. I came from UCSD. I was the Chief Technology Officer at the San Diego Supercomputer Center. And I was the Vice Chancellor of Research at the time, asked me to chair a committee asking about what cyber infrastructure should look like on the campus. And we created a report, and that report was a data-centric kind of infrastructure, where you would store data centrally. One of the reasons I came here to UCI was because they were putting money into building something like that in UCSD. So I think about, like, where do people store their research data today? They store it on USB drives, they store it on a USB attached disk, they store it on their laptop. And in reality, there's pretty significant risk of data loss. And until it happens to somebody, they think it won't or it can't, but it does. And it's like, you think about it and say, you'll spend your money on this part of your research, but you won't spend your money on trying to actually secure your research data in any reasonable way, shape, or form. Some people store data here on the commercial cloud, or just in email. At least the data is very unlikely to get lost there. It's also likely to get lost in terms of you can never find it again. I mean, I know I can't find stuff in my email. So there isn't really a single correct answer where to store data. You can say this is a really bad place to store research data. I think you could say that. This one you can argue about, is it okay to store research data in OneDrive, Dropbox, Azure, Google Cloud? The answer is yes, probably, but it depends on what you want to do. So there's an observation, and UCI is starting to become a little bit unique in this, is that most campuses don't have a place for researchers to store large-scale research data and then work with it. Right? I mean, it's the reality. It's sort of like, well, you're on your own. We can give you a small amount of email space, or we can give you a small amount of cloud storage space, but we don't have a place that you want to start to deal with ones, tens, or hundreds of terabytes of data. We don't have a place for you to do that scale. Right? And the reality is that it's not just big research data, it's kind of any research data. Sometimes the most precious research data is just a really small, volumetrically really small, but it's really complicated to actually get it put together. And literally on this campus and elsewhere, research data is all over the place. Right, so what is the campus research storage pool? Is this something that we've purchased? We fielded, we put in place kind of the first edition of it, and then it's like, well, what other services should be built around it? And so the goals and drivers are, some of them are a place where faculty and their students and their postdoctoral researchers can store their research data. Have high confidence in that storage, sort of get it out of the lab, but it needs to be accessible from all their lab sort of instruments and other sorts of things. Very reliable with close to 100% availability. So that means that storage is more expensive when you say, I want it to be highly available. And we want it to be directly accessible from a variety of places. Right? And this kind of, from a technology point of view, that makes it kind of a little bit challenging. We have to pick some lowest common denominator things. I'll get into that as we go. And then one of the big things is that for adoption, it has to have zero out-of-pocket cost for like the first chunk of data for any researcher on campus. And then it has to have reasonable cost to scale. This is sort of an acknowledgement that lots of faculty research data kind of fits within sort of the terabyte range or 2 terabyte range, right? And then there's a bunch of research that doesn't fit in that. It needs 100 terabytes or larger. And so, it's at what point do you ask faculty to sort of chip in from their research programs to actually store their research data? So the vision, so those are some of the goals. The vision is to provide an enterprise class storage system. Right? It's not, we do our best not to lose data, and we have things that we're doing to do another level of security. But where you store your data is actually just the first part of this kind of whole data problem, right? And that is, okay, so you stored it. I store all kinds of crud on my laptop disk, and I can't find anything, right? So now I need other people that's not me, but like librarians that can help index it and make it available. And then finally, you think about all the way through the publication, data is taken, people are working with it, and finally it has to be sort of pickled and put in a place where the public can get to it if it's data that's backing up the publication. So there's this trying to make data fair. This is this is findable, accessible, interoperable, reusable. The first thing you have to do is to be able to store it, and that's what CRSP is doing for you. And then these next level services come up as more and more people actually store their data in the central place. And certainly we want to be able to incentivize faculty to stop storing their critical research data on low quality hardware in places where data loss is risky. And it needs to complement cloud storage. It's not a replacement for cloud storage. There's a different reason for CRSP to be around. So what's the bottom line up front, right? So if you got up and you left now, at least you would get most of what you needed, what you need to get out of the top. First of all, it's no cost storage space. Right now it's set at 1 terabyte per faculty member. That number is really kind of, we could absorb every faculty member consuming 1 terabyte. There's enough storage capacity to do that. It's about 1,200 faculty members on campus. It could be larger, right? If fewer faculty are taking advantage of it, then we could give them more space. Or if lots of faculty need all that space, can go to the provost and say, hey, they're all taking care of this, there should be a larger baseline. But there has to be usage for people to sort of make those, to be able to make those statements. And then when you get onto CRSP and you look at it, it's sort of apportioned into 2 types of storage areas, right? There's private storage space that's not shareable. It's like your home area. If you're a faculty member, you have a few gigabytes by default of data stored there. And then shareable, this sort of notion of a lab, and I'll put a picture up here in a minute. More space can be purchased at $60 per terabyte per year. It's not really very expensive. That's on par with Amazon's very cheapest level of storage. The difference here is that the data is online. There's no network in and out costs. It's local to the campus and a whole bunch of other things. And the way we come up with that is that it is pure cost recovery for storage capacity. You ask for more storage capacity. We actually have to go buy disk drives, put them in, get them online, and that's about what it costs us to do it with the reliability of the system that's there. There's access. You need to be able to access from PCs, from Mac, from Unix-based systems, through a web portal. There's just a variety of ways to be able to access the data. So it's not just a cloud thing. Data for example, if you're on one of our computing clusters, it's directly mounted. You can just use it. It's just a path, just a file path in the system. All data itself, this is parts of the reliability. All data is immediately replicated. There are 2 data centers on campus. As soon as data is written to one, it is written synchronously to the other data center. So there's always 2 copies of every piece of research data that's out there. Most faculty already have their space allocated. They don't have to do anything. It's one of the difficult things, just asking the question electronically, who are all the latter faculty on this campus? Very, very difficult question to answer. right? One of the surprising things, I've been here like 16 months, so I always get to find surprising things. That was one of them, and then if you want support, you just email it to us. Okay, so it was supposed to be something. So what's it look like? There are 2 data centers, so this is the physical infrastructure. There's 2 data centers. There's about 1.4 petabytes of raw capacity at each data center. That after you take in RAID overheads and other sort of replication issues, gives you about a petabyte of usable space at each data center. Every file is written twice. So it's 2.8 petabytes raw, 1 petabyte usable at the end of the day. Right? To give you an idea, somebody comes to me and they says, but I can buy my disk drive for 3 cents. Why do you charge me $60 for a terabyte? This is part of the reason. Right? It's not just a terabyte we're storing close to 3 for every terabyte that's laid down. Right? There's been a lot of design for availability. We can lose an entire data center and all the data that's in the system is still available. Right? So we can lose any one thing, and one thing gets to be a pretty large piece of work. Then access, the goal is to have your CRSP storage look like a file folder or look like a disk drive. Right? That's the goal, and that's met mostly. Been talking with people, especially in arts and in social sciences. They want to do a lot with video, and we have the right interface to be able to do that. We've been trying to couple it with the right authentication on campus, so that it behaves instantaneous. If you're curious, we can talk about, sort of technologically why that stuff isn't working quite the way we should. All right, so then another question, and Jennifer, this is probably for you and your group, is like, can any research data be there? And the answer is no, right? We haven't certified it to store HIPAA data or FERPA data. A lot of that has to do with just the physical housing, right? That the OIT data center, it's not HIPAA compliant, and the other side, in where the replication site, which is an ICS, is definitely not HIPAA compliant, right? So then there's a question of, well, we have this, I think there's a larger question with Tom Andriola here, will be able to answer it. Should there be something that looks a lot like CRSP, but has this higher level of data protection than what CRSP has. There are features of the file system already in place. The data is encrypted at rest. So if somebody were to walk into the data center and pull the disk drives out, they couldn't actually read the data. Which is a good thing. So it's not like it could never happen, but it's not there yet. So what are the notion of these areas? So when people come in, the first edition of CRSP is sort of focused around a faculty lab, right? And the idea, the notion that faculty members, they have students that are continuously running through their research programs. Where students come, they get trained, they graduate, and they leave. And what you want to do is to have a place where their digital data products are left behind for the faculty member to own. So the idea is that this is the lab space, it's a lab space for the faculty member. They get to decide who gets access to it. We govern that by UCNet ID. They can say, I need this student, this student, this student, this student to have access. I need this other faculty member to also have access to that lab space, right? And it's sort of, you tell us who you want to have. It's explicit granting permission for being able to do that. Every person who's granted access into that space, they get their own folder, right? And in that folder, if I'm in Jennifer's lab, and she gives me access to her space, I have a folder for me. I get to store data there. I get to see it, and she gets to see it. But anybody else in her lab can't see it. And then there is a shared space where everybody who's in the lab can actually see all the data. Right? So but at the end of the day, the person who has visibility of everything that's there, it's stored in the faculty. Right? And PIs can limit how much of their space any particular person can chew up, so that they don't all of a sudden walk into their CRSP space and find out they have no room because somebody decided one of their students decided to upload all of their vacation days.
I've got a quick question.
Yeah.
Can only the lab manager grant this access and do this organization, or could it, or, sorry, can only the PI do it, or can, for example, a lab manager?
He could dedicate it to somebody.
Okay.
He could just say to us, hey, so-and-so is gonna be able to grant access to this
Okay.
space, I don't wanna deal with it.
Okay, and then.
It's
I'll-
not a,
Yeah.
it's
The
a,
PIs don't want to do it. usually.
right.
Okay.
It's a logical thing, right? We do need to have somebody who is responsible for it, and they know, and we could ask them, oh, who should have access?
Okay.
You know, is this allowed? I just this morning had a student who said, I'd like access to Professor Patterson's CRSP lab space. And I go, wonderful. He has to actually tell us, since you CC'd him on the email, all he needs to redo is respond to this email saying approved. That's it. We just need to have something that somebody who's in charge.
That's pretty common.
Got it.
Yeah.
Good.
So if we looked at like my lab space that's on CRSP, that, you know, I have various members in my lab. I have my own space within my own lab. I have other people are in my lab, they have their spaces. I get to see all of this. There's a share folder, and you'll need something here that says share MLab. There's ability for us to put in like a couple of different sharing groups, right? So it may not be, professor may say, have 2 projects or 3 big projects in my lab, and these students should be able to see this project, and these students should be able to see this project. And so we can support that. It's just not automatic at this point. That's a case-by-case basis. So one of our challenges is that we're trying to do multi-operating system support. Right? And it means that we have to go down to kind of a lowest common denominator, right? So storage is available from Linux, it's available from Windows, it's available from Mac, it's available from web. Right? And every one of these operating systems, they use different methods to identify users and to identify groupings of users. Right? Underneath the file system is Unix, so we go down to this lowest level of using Unix groups to identify and categorize people. Now, if you're a Mac user, you should never have to see that level of detail. But if you're wondering why something can happen, you know, hey, I can just give arbitrary access to somebody on my Google Drive. We have to map down to a user in a group to be able to do that, and that's not always the case. So you're sort of here. This lowest common denominator means it's uniform access. If you write on a Mac, the permissions are going to be correct, and you can pick it up off of our HPC system. Permissions are still correct. The sort of bad news is that there's only so much flexibility. Right? It's just a feature of the technology that we don't really have control over. So when we look about that file sort of accessibility and who can see things, in a lab we really define 2 groups underneath. There's the PI group, PI's in it. And there's the lab group, PI is also in the lab group. Okay, so every file that is shared by everybody is written with this group has view of it. Every other file is written with this group has view of it. And then there's an owner. Every file has an owner. Okay, so you think about a student-professor relationship, and there's a file a student writes, the student owns the file, the professor can see it. Okay? If it's put into the shared space, everybody can see, everybody who has access to that shared space can see things. And so we just sort of, it's the way we can govern access, and we can't get, it's difficult to get more granular than that because there's not sort of a notion of access control lists that are universal across all of it. Okay, so if you want access to CRSP, we license something called WebDrive. And so WebDrive will give you a folder view of CRSP, which is nice. It's not exactly a disk drive. This is like where video is a problem. It is more like Google Drive. If you do Google Drive sync on your laptop, you have something that's stored in the cloud and you have a copy of it on your desktop. And then software keeps those 2 things synchronized. WebDrive does a similar thing. But if you have a large file, you may have to wait for the entire file to be cached down on your laptop, and that's not, that's underneath it's using the SSH file transfer protocol. That's the, so it's secured end to end, it's password protected, it's a whole bunch of other things, but there's a reason, and we know about the shortcoming, and we'll talk about it. But when you do things, so there's the Mac version, it kind of shows up, it looks like a disk drive. If you're on the Windows side, it just looks like a folder on your, it looks like a folder on your desktop. And if, you know, for small files, yeah, you're doing a Word file or, you know, something like that, you don't notice it. Things move fast enough that you just don't care. The network is not a problem. For large files, it can get for if you're a Linux person, you can use something called SSHFS, and you can do a user level file system mount, so that on whatever your Unix system is, it will show up. It will show up as a path. And if you're on one of our clusters, it's just an NFS access. You don't have to do anything. CD into a name directory and you're ready to go. Right? So that, and if you write in any one of these things, you can read it out on something else. So this sort of supports for us this workflow where people do computation and they write output on HPC via NFS, and they want to go pick it up on their laptop. They just open up their drive, and the files are there the way they're supposed to be there. People aren't asking questions. It's all too clear. Nobody has any questions?
So how, you said transferring videos might be a problem. How big of videos are we talking about?
So in talking with folks in, I think it was in social sciences and also in arts, is that they wanted to view a video and like go to a certain point in the video. Okay, so what would happen before they could do that is that the entire video had to be downloaded.
Okay, so you're talking about once the file is saved on there,
it's fine, and it's all local, it's interactive.
But just if we acquire a video from our equipment,
so
transferring, it's not too bad.
So if you bear with me, I'll tell you what we're working on
Okay.
to fix that. There's a simple fix in terms of the CRSP already supports the transport that we need. We're trying to match up the authentication so that people don't have to manage a different password. Trying to make it so that you log in with a UCNet ID and your UCNet ID password, and if you change it in the OIT space, it's automatically changed on CRSP because that's what we reference. And for an SMB share, which is what we want to use, getting those two things to talk to each other is really difficult. I think I understand why, but it seems like it's crazy that it's that way. And so there may be some things inside of OIT's identification and password management that has to be adjusted to support it. Right? There's also web browser access. This is, I don't recommend this as a way to access to move things, lots of data in and out. It is sort of, you don't have to install anything on your desktop or laptop, and you can get to your data. You can get to it from your phone. You can do a whole bunch of other things. It's there. Surprisingly, if you actually play a video that's stored through the web browser, it's instantaneous because it's not caching anything. It's just seeking what it needs to do. So it's actually a better interface for videos. It seems a bit strange. There's one-stop shop for CRSP support. Just email us. Right? We're still in the stage where we're trying to figure out how people are using the system, what works well, what doesn't work well, and getting that just getting that interface so that it feels like it's supposed to feel. It's supposed to feel like it's a local drive on your system, and that people can see it. That's what it's supposed to feel like. How getting it so that it always feels that way is certainly a technology challenge, and it's the only way. The only way I know is just to talk with people. Right? I've gone over and helped people get their CRSP shares set up. It's fine. Right? That is what we're here for. So we already have collected some feedback. This isn't all of it, okay? But these are sort of the big ones. How can we share with users outside of UCI? And that's the first one. I have data. How can I share outside of UCI? right? And so today you can always sponsor UCNet ID and have that UCNet ID part of your lab and your faculty member and you're ready to go. That's not terribly convenient, or doesn't really hit all use cases. Another one that we're working on now, and we're working through the details, is authenticated read-only access to data. Okay, so we can do that where we use in common that people who have identity from another university, they can point and say, I'd like that identity to be used, and then we can have a file sort of access that says, hey, this person from this institution is allowed access to these files read-only. The reason why read-only is easy is because down on the system, we know who owns the file. It's part of our Unix group, Unix ownership, Unix grouping. Read-write is much harder, right? Because then we have to get into sticky questions, and there's not a universal answer. If somebody from Boston University is allowed to read-write something on CRSP, who owns that file? Is it the faculty member who has the space who owns the file? Is that remote user who owns the file? If it's the remote user, then we have to gin up an ID for them so that there will be correct ownership permissions on the underlying file system. It's not, there are not easy answers. And if you go and you look at, oh, I can do this on Google Drive, or I can do this on a variety of other things, it's because yeah, you can do that on Google Drive, but I can't NFS mount Google Drive on HPC and allow you to directly, allow you to have your programs directly access that data. You have to do something in between. It's just limitations of technology all the way around. Okay. So CRSP doesn't work for video editing. Can it be fixed? The short answer is yes. The timeline I don't know yet, because I have things that are outside of my group that people have to get sorted out. The underlying technology is SMB, right? And Mac supports an SMB, has an SMB client. Windows has an SMB client. Linux has an SMB client. It's all at authentication. The advantage of this is that if you mount CRSP through Samba, it looks like a disk. There's no local caching. You don't have to cache an entire file. It looks and behaves just like a local disk. So then you need to do random access into a file. It just seeks to the file and it starts pulling the data from at that point. So that's already there. It's already highly reliable in terms of the underlying technology that's there for CRSP. It's just getting the authentication matched up with the authentication systems that are provided to us by OIT. So we're working on that, and it's just as soon as we get it figured out, it will be a production thing, because it's just all it is the identification part. The rest, all the other stuff. I have more than one group of students. I'd like to have 2 different share areas or 3 different share areas. Can you support that? And the answer is yes. We can do that, have the mechanisms to be able to do that. You just have to ask us, right? It seems to be, it's not very common. Maybe had half a dozen groups ask us for that. Can the adding and removing UCNet IDs from my lab be self-service? Right now you have to send an email to us. We're pretty quick about responding. We're working on that. It's just a software development effort to make that happen. And then are there other storage options at RCIC? And the answer is yes. There are other storage options, right? And although the talk says it's going to talk all about CRSP, you need to know that we also have another scalable storage offering. It's a parallel file system, and data there is only accessible directly from our clusters, right? And we have no expectation that would make data stored here available in the way we have data stored for CRSP. Right? It means we have to go duplicate a whole bunch of infrastructure, and it isn't cost effective or people time effective. Underneath, there are 2 different storage system technologies. If you care, we use BGFS, the parallel file system. On CRSP, it's IBM Spectrum Scale or GPFS. It's another parallel file system. Just for this one, this one has different capabilities. So some of the things that are different is on the right-hand side, there's a single copy of all data. Right? On CRSP, everything is in 2 places at once. And we're working on everything being in 3 places eventually. So 2 places instantaneously, and then on sort of a more kind of lazy backup, like once a day, we'll offsite replicate data to an offsite data center. The goal here for us is that if somebody is going to store and trust RCIC with their research data, it's not great to have it unavailable. It's absolutely terrible to lose it. Worst thing in the world, you know, literally we'd be holding a research career in our hands. It's pretty good now. We need to do one more thing so that the likelihood that we've actually lost data permanently is almost zero. Yeah.
Currently, the both data centers are on campus.
Both data centers are on campus.
In the same building?
No. No, they're about 3/4 of a kilometer apart from each other. Right. So that's a risk, right? That there's no offsite, and there's the money in my budget to be able to do offsite replication of data. If you look at that offsite replication of data, it's at that site it's only a single copy of data, and we can do lots of compression, and we can do data deduplication. We can make it slow so that we can store as much data as possible and as little money as possible.
So you're working on doing it offsite though. Do you have an approximation of when that might come online?
That's probably next summer, and I don't think anybody will. From a access point of view, you just wouldn't know. It would just be, hey, we've increased our data reliability.
Right.
When I started, I said I was at SDSC, the San Diego Supercomputer Center, for 19 years. When I was like within my first 5 years that I was there, I got to witness losing multiple terabytes of data out of the tape system because it was a single copy of data. And tapes were literally shredded. And there was no other copy of that data, and it wasn't my group. I just saw that and said, I never ever want to be in that position when that happened. The other thing is the data here, the data in CRSP is encrypted at rest. We store it offsite, and will also be encrypted at rest. We do have 7x24x365 commercial support. There is a company that monitors our servers all the time. So when we're not here, it's weekends, we get to take time off too. If something goes wrong, they can actually dispatch. If it's a hardware issue, they can dispatch Dell service. They have access to the system, so if they need to do a software fix, they can do that. And the dollars are, this is $60 per terabyte per year for our parallel file system storage. It's $100 for 5 years, $100 per terabyte for 5 years. And this is literally just the cost. This is just the cost of the hardware. There's no software cost in there. There's no personnel cost in here. For this one, this is just the cost of adding additional storage. All the licensing for the software has been taken care of by the provost. All the cost of the people to manage it is already handled by RCIC's budget. This is just recovery for additional space. Okay. So if you're interested in some of the technical detail, so the hardware it's all Dell hardware, Dell servers and Dell storage. The networking is Dell and Mellanox. I said there's lots of things that can go down. We can lose an entire network and the system will still work. So everything that's connected is connected to 2 different networks. Okay. The file system is IBM Spectrum Scale. We're also using some other software called HH Proxy, which is a commercial load balancing. So when you come in, you go to one thing, there are actually 6 servers in the back that can give you your Samba request, or give you your HTTP request, or give you your SSH, your SF2P, SSHFS request. Right? So there's 6 servers, 3 are in one data center, 3 in the other. They all have symmetric access to all the data. And then, so these were pieces that, this is what we purchased. It was about a $1.2 million RFP. We had to add a little bit more to that. Gives you an idea of what the expense of the system is. That's the cost for, that's the petabyte of usable space, plus the licensing of the storage software, plus support for 5 years. Right, so that's done. Nobody's asking that's already paid for. and thank Provost Livernia for actually sending the money to RCIC so we could do that. So that cost is done, and we don't ever try to recover any of that. These are things that we had to build to sort of get the rest of it so that we could get access across different operating systems in the money. If you look at it, the clients are up at the top, and this is what the system looks like. There's a storage cluster in one data center, another storage cluster in another data center. You can lose anything in here, and the system is still up and available. And there's lots of places where you can lose something and you don't even lose access to data. So, for example, if you have a storage server here, it has disks underneath it. It also has physical paths to disks over here. So if the storage server fails, this one can take over for it, which is nice. Sort of keep the system up and running. We certainly did experiments where we literally walked into our data center. We forgot to tell the guys who were monitoring the data center that we were going to turn off all the power in a rack. We just took the rack PDU and we went like this to the main power breaker on the PDU, and we killed all the servers. Nothing, wasn't a graceful shutdown or anything. It was to simulate what happens if the power goes out in a particular data center. And so we killed it, and the system kept running. Right? There weren't interruptions. We did immediately have the people who were monitoring the data center come in and say, "Oh, what are you guys doing? And why didn't you tell me?" I said, "Oops, sorry. We promised not to do that." So there's high availability hardware, and there's enterprise scalability and resiliency. So we have it's really 2 petabytes in a single namespace, and since everything is doubled, it's effectively 1 petabyte. GPFS is known to support, meaning they have known instances of 18 petabytes in a single namespace. It scales to almost an exabyte into a single namespace. We'll never get close to that. I think at UCI, we won't even get close to this. So from our view, it's sort of effectively unlimited scalability in terms of capacity for the campus. It is an active cluster in terms of both sides. It's not like there's an active side like in the OIT data center, and the ICS side is passive, just waiting there to take up backup. Depending on where you come through the campus, you might be writing primarily to ICS and the data is immediately replicated to OIT. Or you might be writing to OIT primarily and the data is replicated, it's symmetric. So everything's available all the time. There's lots of performance. I can upload and download from my office. I have a good network connection in my office. Not everybody does on this campus. But I get essentially line rate. So I have a gigabit connection out of my office. I get about 100 megabytes per second reading and writing to CRSP, okay, over the network. So it does work. If you're not getting good performance, I'd like to know about it because it's likely a network issue. So almost certainly not a crisp issue. There's lots of performance capacity in the system. So how do people get started? Faculty accounts should be already created. We still don't have a way for picking up new faculty that just started. So we may not have them. They just need to send us an email and we set them up. It's a very straightforward process for us to do that. If you wanted web access to log in, then you just go to that one site. And then if you want other access, you want to look at other access methods, again, you come to our website to sort of take a look at these things, and it tells you where to go to get software and how to configure it. And then finally, and we can get to finish a bit early, which is good. There are lots of people that helped us with this in OIT. So Dana Rood, who retired, who retired on July 1st. He was really a driving force within OIT to sort of make sure that that the funding would be there and that there was enough impetus in terms of getting an RFP written and started execution before I even arrived at UCI. Other folks, there are a number of folks here that are in the networking. Chris doesn't work without the networking support on campus. There are folks that are in the data center. Chris doesn't work without data center support. folks over in ICS, runs the ICS data center, and is basically that doesn't work. CRSP doesn't work if those people don't help out. There are people who are in RCIC who have been critical. Alan Sciano, he was the CRSP project manager, and he was the interim director of RCIC. He's retired. Harry Magdalen's also retired. Peter Herring from Archistream, this is the company that provides us support, that's sort of the 7x24 by 365 monitoring. And then finally, I'd be remiss if we didn't thank sort of the provost and sort of the leadership at UCI for having enough vision and giving us enough room, financial room and other kind of room to actually put it in place. But the challenge for me is how do I get more faculty to actually use it? It's a system they don't have to pay for, and I think it's highly valuable for them to put their data there. Okay, so I'm going to end there. Yes.
Okay, another question.
Yeah.
When you said that the faculty already have accounts, so does this mean, but they may have an account, but they still have to load something on the computer maybe first, or is it?
So if they do a web drive if they want to do things through WebDrive,
Yeah.
WebDrive needs to be loaded.
Okay,
If they want to just go
And they
through
can
their
get that from
browser
their
and see
website?
that they have space,
okay.
they don't have to
Maybe
do
that
anything
first.
except browse to a thing. You'll get asked to type in your UCNet ID and password, and if you're already if you're already part of two-factor authentication, it'll ask you for your second factor.
Okay, for the, what was it, WebDrive, is that something they can get from your website?
From our
If they want to?
website,
Yeah.
it's site license for the university.
Okay, so the.
It's really, yeah, and they need to use that site license version.
Okay.
And they can use it, WebDrive is not just for accessing CRSP. WebDrive is a generic thing to let you talk to all kinds of remote storage things.
Okay, so maybe.
They can use
already have-
WebDrive to talk to, they could use it to talk to Dropbox, Google Drive, they have a bunch of other things in there, but
Okay.
we have instructions for how you go through and set up.
So maybe they already have it for some other purpose that they're using. I don't-
Possibly, and WebDrive is not, I mean, it's the client we support, but if you have faculty or researchers who are comfortable using something like FileZilla, it's
Mhm.
completely compatible with that. It's a straightforward setup. CyberDep is another client that they could use.
Okay.
Underneath the transport is SFTP.
Okay.
So it's the secure shell file transfer protocol. That's the underlying so any client that understands that they could use on their desktop. They don't have to use WebDrive. It is the one that we have licensed for campus. Okay. Yeah.
I guess we do have access, and we try to create this for our lab space.
Mm-hmm.
The PI has designated me to be able to do all of this, and
Yeah.
I kind of kept running into roadblocks about how to actually use it. I think it was just my own misunderstanding of the system.
Okay.
Because we
So
don't
where do you
have-
want to use it?
well, we
Where do you
don't-
want to use it from?
I mean, you were saying pretty much the web is not your best bet using WebDrive. It's just a matter, I guess what I'm trying to do with it, I'm not sure if it's possible. Because we currently have what we call a server, but it's not really a server, but it's something local that we all access and we all have folders.
Mm-hmm.
And I can just tell our Buffalo drive to back up whenever I like. And I do it once a week myself.
Mm-hmm.
And there, it's only there that it's on like an external drive, and so I recognize that this is
Yeah.
not, it's better than having it on other
Yeah.
areas, but I'm trying to now use this as a redundancy to what we have, because we're very comfortable with this, but it seems like I'm having a little difficulty with.
Yeah, I think that we can talk offline about this and more. I'd like to get you to the place where you looked at CRSP as your primary storage, and what you had was just sort of, oh, well, that's just another copy of it, but really my storage is in CRSP, and that's how we use it.
I think if
Right.
it could accommodate what we need, because we do have a lot of video files that we use for like animal behavior and things.
And what
like
department
that.
are you in?
We're in the School of Medicine, Pediatrics.
Okay.
So I think I was working with Joseph at first, and Alan chimed in, and
Yeah.
so we were, and then I just kind of set it aside because I got busy.
Yeah, as I said in my talk, the video files are challenging not because of their size or anything, it's because of the tools that access them. It depends on what you're using, but even things like VLC, which was designed for streaming things. If you have a local file, before it will play frame one, it wants the entire file locally. And that doesn't work with either WebDrive or, doesn't work with WebDrive or with SSHFS or CyberDoc or FileZilla or any of these things that you need an SMB mount for. And we're working on that, especially for video. We know it's a problem. We thought, oh, this is great, WebDrive will do everything, and then I have talked to various people, you gotta go, it doesn't work, and underneath you have to figure out, oh, okay, so this piece that's hard, we actually do have to do this hard thing. This is fine, that's what we're paid to do, it's not,
I'd love to get any help on
yeah.
I have another question related, I think related to this. So we're not using this yet, at least I don't think so, but I think we want to start similar to you. And so I'm trying to think from the user, from all the students or the people in the lab, like their routine. Should it be every time they generate a file, like instead of just saving it on their computer in their, whatever their folder in their documents, they should save it directly to here
Well, if it's,
first? Or
I
should
would
it be
just
more
have
of a backup?
I would just have you could use it as backup. I think that's the better use is
Okay.
that, you know, if you have a lab full of students and they all have their own desktop, you have each of them sort of, they map the lab folder in CRSP.
Okay.
And they can either write to their folders or they can write to the share folders. Just depends on just depends on what's required for the particular person. But as soon as, if it's done there,
Mhm.
then it's immediately available to everybody,
Yeah.
right? And it's sort of like, okay, it's reliable and it's online, and it's a lot different than saying, oh, should I do this and then make a copy of it? It's like, just use it directly like it was
So
your
kind
own.
of like I
local
think
storage.
people are using Google Drive, like that's new to me, but like the kids, my kids in
Yes.
school, that's what they're doing. That's their primary,
Yeah.
where everything is,
Yes.
instead of saved onto the computer,
Yeah.
which is.
And
how we used to.
if you generate a file, so if you're on a workstation or a laptop and you're generating it locally and you're using WebDrive, it gets synced in the background to where it goes. Just like Google Drive, there can be a delay. If you have a Google Drive or you have OneDrive mapped on your laptop, in that sense it works exactly the same way.
Okay.
The other nice thing about WebDrive is that you can tell WebDrive, and this doesn't work great in shared situation, works better in sort of a personal thing that says, look, I want these folders permanently cached on my laptop so you can work on them offline. And so if you're offline, you can have access to those files. You can do the same thing with the Google Drive client. You can select folders and say, I'd like these to be permanently, and then when you reattach to the network, it
Then
resynchronizes.
it syncs it, okay. Oh, that's good. Yeah, I think we'll need to kind of change our routine of how we do things for this to work better.
Yeah, and that's not, I mean,
It's
that's
not
not a
bad.
surprise to
Yeah.
me because it's sort of like, well, I almost like to say, I still remember, I wasn't very big, but I still remember the first time my parents brought a microwave oven home from the store and put it in our house. This was in the late 60s in California. And nobody knew they needed a microwave oven because they had never had one.
Yeah, you didn't know you needed it, yeah.
This is sort of like, oh, you do things because this is what's been available for, from this time going backwards. It's not an instantaneous change, right? And so, I want to know, like, well, where does it work and where does it not work? Eventually, it should just be like, everybody should say, yeah, it's in CRSP. Like, why would it be anyplace else? Right? That's eventually where we want. That's eventually where I'd like to see research data. Because if it's there, then the next thing is it's already in a centralized place. You think about publication, now we can say, oh, we already have it here. You don't need to transfer it after the fact to something or other for publication. Somebody else, it could just be, I don't know, tell the library, hey, this is where the file is inside of CRSP. Please put it over into, a permanent place, give it a DOI, do all the right things with it. If at least long history. I've been in the university for a long time, not this university, but the University of California for a long time. And if you ask a researcher of any type to, after the fact, do something with their data, and they've already got the publication, they won't do it. And then that data gets lost. Over time, it gets lost. I think that's a bad thing for the university as a meta statement, right? And so this is just trying to get it to where, okay, we're at least storing it into a common place. Okay, then we can start thinking about, okay, now we can think about the next thing, so that as soon as the data is born, you can think about things like, oh, it gets marked up, you can tell exactly what it was. If you're coming out of stem cell research, it's like, oh, this was this data for this particular experiment, it's got all the markings around it, and that just goes through with it, and the data's already there, the metadata is already there. We're a long ways from that, but that's what we'd like to be. That's what I'd like us to be.
Isn't what NIH is asking now? Like you have to make your data available to anybody who, after your research is done.
Yeah, but they don't, yeah, but then,
Very-
but if you don't have institutional support for that, how do you do it? Especially for large scale data. You know, if I think about folks that are in genomics, right, and they have a whole bunch of sequence data that they have. And they said, well, I had the money to support the space for this sequence data, you know, while my project was active. But that
Yeah.
project's been over 5 years.
Yeah.
Who pays for that data and where does it reside? Another thing is that if you have it in a centralized system, then you can go again back to the university and say, hey, this is, you know how we pay for our, you know, hard libraries? This is the digital library part of it. You need to pay for the long-term storage. You need to pay for the long-term storage of this data. It's not changing, right? If it's there for publication, it's static. And it means that if you look 10 years from now, what seems like a lot of data is going to seem like a small amount of data because it's cheap to store. But somebody has to own that, and it's the university that needs to own it. University needs to own that. But I don't know what, you know, NIH can say, yes, make it available. What's that mean? Somebody have to send an email to a professor to make it available? Or if that faculty member leaves, faculty member dies?
Yeah, I mean.
Right? Then what happens to it? It's actually, it's a large problem. This is like a very first baby step.